Welcome to our YouTube channel, and in this video we will see the difference between ArrayList and LinkedList. So what is the difference between ArrayList and LinkedList? So as we know that ArrayList and LinkedList both are the part of collection frameworks, okay, and they are many similarities, they have many similarities, but even then there is a difference between ArrayList and LinkedList. So what are that, and how it is different to each other, okay. So the points on the basis of it we will differentiate array list and linked list is implementation, manipulations, implements and act, storage and access, and memory location, and default capacity. So these are the point on the basis of that we will differentiate to both of them. So first point is internal uses of what they internally use. So ArrayList internally use dynamic array and linked list internally use doubly linked list. Dynamic array means ArrayList internally uses dynamic array, that is size can be grow, static and dynamic. So static array, that size we cannot increase it, but dynamic array we can increase the size of that, okay. And linked list, doubly linked list, which has a 2 pointers, means it can go backward and forward both the directions, so it is called doubly linked list, okay. Now where it is located, array list and linked list. So array list is here and linked list is here in this tree of collection framework. So the root interface is table interface, then come collection, and collection has other interface, that list, queue and set. So list, queue and set are the interface also, okay. So array list here and linked list. So array list actually implement to list interface, and linked list implements the list and queue both. So internally work is also like that, okay. So array list will work like list, and linked list will work like queue and list. So next slide that show us in array list how the elements are stored. So there is a index values, and in here is value. So each values are associated with some index, so we can access by any index. If I wanted to at the index of fourth number, what is the array elements, so by index I can access it. Now the linked list, how it is stored. So there is a every element, every data fields, every elements has a 3 fields, okay. Middle shows the data fields, actual data, and this both means at the left hand side and right hand side show the node. Left will be show previous node and right will show the next node. So complete list will look like this, where 4 elements is there, A, B and C, and each of them pointing to each other, and this is the link. So in this way linked list is prepared internally, okay. This is the difference. Another diagram we show that array list is index based and linked list is like linking to each elements and store the elements and address pointers. Now the manipulations, on the basis of manipulation, if we differentiate array list and linked list, so array list is slow and in concept of manipulations, and linked list is faster if we want to more operations are manipulation. So linked list is faster and array list is slow. Why array list is slow? Because in a array list we require bit shiftings, so that's why it is slow, okay. And we require bit shifting, so it is slow, and linked list is faster because we don't require any type of bit shiftings. Now the diagram we can see in array list, here all values are stored by the index values, and if I wanted to remove this 55, then what will happen, all this element will bit shifting is like that. So after this, if I wanted to remove this element, so after this coming all the elements will be bit shifted, will be required, so we have to shift them. So this is happened when I wanted to remove 55, okay. So this is the list after removing. Now if I wanted to remove 23, so what will happen, 23 is located here, so after that coming all the elements will be shifted to here, okay. So bit shifting is required, it means extra operations, extra things is required, so we say that array list is slow, okay. And about the linked list, and linked list, that much operation not required. Means here is a three elements. Suppose these are the three boxes which show the elements. So what will happen if I wanted to remove the middle elements? So I have to break the link. Means it shows the next, it shows the previous. So linking of this will next point to here, and previous of this will be here. So this will be free, and in this way it will be removed. So we have to just change the links. So here easy to manipulation means remove, or remove or manipulate means update. That is coming the manipulation operations. Okay, another example where three elements are stored, and if I wanted to remove this one, so again the same things that the next of David will be would will be Miriam, and now the Miriam previous node will be David. Okay, and Johnson, in this way Johnson will be deleted, because we linking, we break the linkings. Okay, so this is the way to delete the link element in a linked list. So that's why it is faster. Okay, now the next is how it is implemented internally. It is implemented list, so it will act also like a list. And link about the linked list, so internally it is implementation list and queue, so it will work also like a list and queue. So this is another difference. Now the next difference is if we say in what cases array list is better and what cases linked list is better. So if I wanted to store the elements or access the element, linked list, sorry, array list is better. Store the elements means if I wanted to store the elements, I just need to by the index value I can store them, and access by the index value I can access easily. Okay, so it is better for that. But if there is a manipulation, so linked list is better, because in a array list, as we know that bit shifting is required, that is take extra time, extra efforts. Okay, so it becomes slow operations. If manipulation in a array list, we will try. So better for the store than access. Okay, next difference is memory locations. So array list memory locations is index based one by one and continuous. So that's why we say that its memory locations is continuous. Elements are stored in array list is continuous, but in a linked list element is not continuous. Okay, the next is difference is what is the default capacity. So array list default capacity is 10, means initially it is assigned 10. And after that when 10 is stored, then it will increase. About the linked list, so there is no case of default capacity, means in at the initially it is empty linked list. It is empty list, so no default capacities is there, just empty list initially. If we see the what is in initial capacity or default capacity, so it is empty linked list. Okay, precise, we can say array list is resizable array, and linked list is linked list and list interface, doubly linked list and list interface implements. Okay, so in what cases array list is better? So if frequent operations is requirement, means access, if we wanted to access, in that case this is better, and linked list is better in insertion and deletions. Okay, so if you wanted to insert or delete, we can fast, it is best for that operations. Okay, next difference is, in what cases is worst, as already we know that insertion and deletion is, in the case of that it is worst because required bit shifting, means all the elements will be shifted. If you wanted to any of the location, if you wanted to store in a middle or anything, we required bit shifting, means the elements all after coming, all the elements will be shifted. Okay, shifting is required. But in what cases linked list is, sorry, here you will come worst. Okay, so in what cases, if we want, if we frequent operations is retrieval, in that case linked list is worst. Okay, so complexity, so array list complexity big of 1. If there is access if we wanted anywhere, if we wanted in a, if there is 1,000 element or any, or how much there is, whatever the size, access in the case of access it will take big of 1 complexity. And if you wanted to insert remove at the end, okay, in the list, then also big of 1 means take a low complexity, and complexity will be required and big of n if we wanted to insert or remove, rather than end anywhere else it will take a big of n. So this is the complexity, worst and best complexity. Same things about the linked list. So linked list is better, means big of 1 if we wanted to insert or remove at the start, okay, and big of n means that complexity, large complexity, worst complexity if access and insert or remove. If we wanted to access, it will require that much, and insert and remove, why complexity of big of n, because we have to go to that location, means one by one we have to traverse and we will go, and then we will be able to access that element, okay. But not in ArrayList, this is not the case. Directly by the index we can access that, so that's why it is a big of 1 in access cases, okay. And here big of n because traversing is required, so that's why it is access and insert. And if we wanted to insert or remove, then also we have to go there, and then we'll be able to access or remove. So that's why it is complex. So these are the difference between ArrayList and linked list. I hope all the points is clear. Thank you so much for watching this video. Please like, share and comments. Thank you.